Well, welcome. In this video, we're going to be looking at combinations, which is something that we're going to be using throughout this entire chapter. So it's important to make sure you understand this concept. But before we talk about this concept, let's review what a permutation is. A permutation is something that we learned about back in chapter 6. And a permutation is a situation where the order of things does matter. So in reality, instead of having something called the combination lock, it should be called the permutation lock because the order of the numbers matter. That's an easy way to remember it. Because with the permutation, if you had something like 10, 6, 10 as the lock combination, that's different from 6, 10, 10. So 6, 10, 10, 10, 6, 10 would be two separate, completely different permutations. Where a combination is where order does not matter. For example, if you go to Burger King and you purchase a cheeseburger, some French fries, and a Coke, that's going to be the same order as if you ordered the Coke first, then the French fries, and then your cheeseburger. So the order does not matter with the combination. The order does matter with the permutation. Let's look further at another example here, and then we'll talk about how we actually figure out how many different ways there are to a combination by using a formula. So let's start by, again, looking at the example that's behind me here, and then let's look at that formula. So here in this particular example, it says, suppose you're making trail mix and have 5 ingredients to choose from. You decide to make small bags of mix, each with a different selection of 3 ingredients, rather than a big bag with all 5 ingredients. How many bags can you make so that each bag has a different mix? Well, the way that we would figure this out is, well, first off, before we get to that point, let's say if we had these 5 ingredients: almonds, peanuts, M&Ms, cashews, and raisins. And instead of using all 5, we're selecting 3 of these. And this is what I'm saying right here, is that if I picked A, which represents the almonds, and P is peanuts, and M is M&Ms, so if I picked almonds, peanuts, and M&Ms, that's going to be the same mixture as having the M&Ms, peanuts, and almonds. So they mean the same thing. So this is where order does not matter. Now the way that we'd set up this question is the fact that since there are 5 items and we're selecting 3 of them, we're going to write it as 5 choose 3. So in general, when we write an equation or when we write a combination, we always start with N representing the total number of items, followed by C representing the fact that we're using a combination here, followed by the R. And the R represents the number of items from the total that we are going to be selecting. Now there's another way to write this. It's not quite as common, but that's using parentheses and using our value for N on top and R on the bottom. It's not a fraction. Okay, so it's not a fraction, even though it looks like it might be a fraction. It's not a fraction. There's no fraction bar. We're not dividing. Just another way to write a combination with the number of items that we have to choose from in the top for our N, and the number that we're selecting out of that total, the R, would be on the bottom. Now the way that I like to read this is, just like they say here, N choose R, so 5 choose 3. Now how can we figure that out? We're going to use either one of these 2 formulas. Personally, I prefer the second one. That's the way that I'm going to set these up, but either one of these would work. But looking at the second example here, we would take N factorial. Let's review factorial. Factorial means that we take whatever that number is times all the numbers before it all the way down to 1, divided by N minus R factorial and R factorial. So let's look at this example here so we can make sense out of that formula. So the restaurant menu has 10 appetizers and 12 main courses. A group of people decides they want to order 6 appetizers and 4 main courses. How many ways can they do this? Well, let's start with the appetizers here. So now there are a total of 10 appetizers, and we're going to be choosing 6 out of those 10 appetizers. So the way that we're going to set this up is, again, using this formula. It's going to be 10 factorial over N minus R. Now 10 minus 6 is 4, so it'll be 4 factorial, times R factorial. Well, R in this case is 6, so it'll be 6 factorial. Now remember what factorial means. It means we take and write this as 10 times all the numbers before it all the way down to 1. And we would do the same thing now for the 4 factorial and the 6 factorial. Okay, now what we're going to do here is we're going to simplify this fraction. Before I start to multiply a bunch of numbers together here, we're going to simplify this. So to simplify this, what we're going to do is we're going to take and see what can we cancel out from the top and from the bottom here. So I see that I have 6 all the way down to 1 here in the denominator. I also have 6 all the way down to 1 in the numerator, so those would cancel each other out. Now in the denominator over here, we have 4 times 3 times 2 times 1. And I can see that, oh, well, 4 times 2 is 8, and that would cancel out the 8 from the numerator. The 1 really has no impact here, so I'm just going to cancel that out because I don't need that. But 3 goes into 9 3 times. So now I can simplify this easily by taking 3 times 7 is 21. 21 times 10 would be 210. So there's 210 different ways that we could combine those appetizers. So 210 different combinations there. Now let's do the main course. So for the main course, there are 12 main courses to choose from. And out of those 12, we're going to be selecting 4 of them. So again, just like we did before, we'd have 12 factorial. In our denominator, we would have 12 minus 4, which is 8. So it would be 8 factorial times r factorial, which would be 4. Also, here's a little hint for you. In our denominator, the 4 and the 6 added up to be 10. Here we have 8 plus 4. That adds up to be 12. That's an easy way to check to make sure that you have it set up correctly. Now let's go ahead and simplify or set this up. So it's going to be 12 factorial. So it's going to be 12 all the way down to 1. And then we would have the 8 factorial and the 4 factorial. Now, this 8 factorial, and here we have 8 all the way down to 1, those would cancel each other out. So these would all be gone along with these because they would cancel each other out. Now we have 4 times 3 times 2 times 1 in the denominator. Now 4 times 3 is 12, so that would take out the 12 from the numerator. 2 goes into 10 evenly. 2 goes into 10 5 times, and that 1 doesn't matter. So in the numerator we have 5 times 9, which is 45, times 11. I'm going to show you a little trick here to do this without a calculator. 11 times 5 is 495. Here's a trick. When you multiply 11 times any double-digit number, the 4 and the 5 are going to be the first and last numbers in your answer. To find the middle number, we would just add these two together. 5 plus 4 is 9. And if we do have a number larger than 9, we would just carry over that other digit to the hundreds digit. So if these were add up to 10, let's say, we would take and have 0, and then we would have 4 plus 1 would be 5. So we'd have 505 if that were the case. That's a little trick to multiply 4 times, or any number times 11. But anyhow, you get 495. But now the question says, how many ways can they do this? We want to figure out the total number of ways that they could arrange or get these different appetizers and main courses. So what we're going to do is we're going to use what's called the multiplication counting principle, which tells us that we would multiply the number of choices in the first category times the number of choices in the second category. So to find the total here, we would take 210 times 495. And that we would need our calculators for to get 103,950 as your answer. Once you guys try one on your own, so once you guys work this one out, I'll help you get it started though. It says the class is 10 boys and 15 girls. The committee of 5 is to be chosen to represent the class at a group meeting. So it is decided to pick 2 boys and 3 girls. How many different committees are possible? So first you're going to figure out how many different combinations there are for the boys. And there's 10 boys to choose from, and you're selecting 2 of them. And for the girls, there are 15 girls to choose from, and you're going to be selecting or choosing 3 of them. So once you guys work this one out, and then once you figure out the total number of combinations for the boys and the total number of combinations for the girls, multiply those 2 answers together to get the total number of different committees that would be possible.
So why don't you guys pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here. You should have gotten a total of 20,475. Now, how would you get that? For the boys, again, since we have 10 choosing 2, we'd have 10 factorial over 8 factorial times 2 factorial. So the 8 factorial, 8 going down to 1, would cancel out 8 going down to 1 in the numerator. And then we'd be left with 2 times 1. Well, 2 goes into 10 5 times, and the 1 doesn't matter. So we'd have 5 times 9, or 45, as your answer. For the girls, we'd have 15 factorial, so 15 down to 1. In the denominator, we'd have 12 factorial, so 12 down to 1, and then 3 factorial, so 3 down to 1. Well, that 12 factorial, so 12 down to 1, would cancel out 12 down to 1 in the numerator, leaving us with 15 times 14 times 13 in the numerator, and 3 times 2 times 1 in the denominator. Well, the 1, again, wouldn't matter, but 3 would goes into 15 5 times. 2 goes into 14 7 times. So 5 times 7 times 13 is 455. To figure out the total number of different committees possible, we would take the 45 different ways that we could arrange the boys, or that we could select those 2 boys. Take the 455 ways that we could select those 3 girls. Multiply those together, we get 20,475. Let's look at another example. This one, it says the vocabulary test has 30 items. Each correct answer is worth 1 point, and each wrong answer is worth 0 points. How many ways are there of scoring 25 points? Well, the way that we would figure that out is the fact that, well, if we're getting 1 point for each correct answer, and we're trying to figure out how we could score 25 points, well, that would be the same as getting 25 correct answers. So we have 30 questions total. Now we want to get 25 of them correct. Now, I'm going to show you this one, how you can use a calculator. So what we're going to do is we're going to type in NCR, meaning we're telling our calculator that we're going to have N items, we're going to be choosing R of them. In parentheses, we're going to say what the actual numbers are. So there's 30 questions. The comma button is down here next to the O. If you have this calculator, if you have the gray calculator, it's going to be down to the right next to the plus sign. We want to do comma, and then we're going to say, well, how many of those 30 we're going to be selecting, which is 25, close it off with parentheses, and hit enter. We have 142,506 ways. That would be your answer. Now, there's another way that we could look at this. We could also say, with the same 30 questions, because getting 25 points would be the same as getting 5 of them wrong. Well, watch what happens when we do this on our calculator. Again, doing NCR with the parentheses of 30, and getting 5 of them wrong ends up with the same exact solution. Let's look at this next one. Bill drives to school, and the route he takes has 5 stoplights. If he reaches all the stoplights on green, then it takes him 12 minutes to get to school. But every stoplight he reaches on red slows him down about a minute. In how many ways can he be slowed down to get to school in about 15 minutes? Well, that means that the fact that we're trying to figure out how long it would take him, or how many different ways it could take him to get to school in 15 minutes, means that he'd hit 3 red lights. Because those 3 red lights would tack on an extra 3 minutes about to get us there in, like I said, 15 minutes. So if there's 5 stoplights, and we're going to choose 3 of them, well, if you do that on your calculator, you get 10. So there's 10 different ways for him to get to school in 15 minutes. So you get one that's a little more complicated. Here it says the school requires that all participants in a sport submit to random drug testing. During one round of tests, 25 students are randomly selected from among the 250 students participating in sports. What is the probability that the quarterback of the football team and the goalies of both boys and girls soccer teams are 3 of the students selected? Okay, well, the way that we're going to figure this out is we're going to take the number of ways to choose a 3, and we're going to multiply that by the number of ways to choose all of the others. Now this is different from the previous problems because instead of getting just all the possible combinations, we want to figure out the probability. So probability is going to be a fraction. So the denominator here for this fraction, remember anytime we're trying to find a probability, it's a part divided by the whole amount. So we're going to have the total amount of combinations would be in the denominator here. Let's start with this first part. The number of ways to choose a 3, well, there's 3 athletes. We want to figure out how many different ways that we could choose all 3 of them. Again, that's the quarterback and the 2 goalies. Well, if we have 250 student athletes and we've selected 3 of them, now we're down to 247 student athletes. And if we're randomly selecting 25 students, and we've already picked 3 to be these 3 here, now we're down to 22 students that would be selected out of those 247 student athletes. Out of our total number of combinations would be, well, the fact that there's 250 students and we're choosing 25 of them. So we can do this in our calculators. First, I want to show you what 3 choose 3 would end up being. Again, doing NCR, and if I put in parentheses 3, comma 3, we get 1 as our answer. Anytime the number of items and the number of items that we're selecting are the same, your answer is always going to be 1. So this essentially will be 1 times, then let's do it this way. Let's do a control divide to get a fraction here. So in our numerator, we're going to have, again, NCR. We're going to have the 247. We're going to choose 22 of them. Go down to our denominator, and we're going to do, again, NCR, where we have 250 students, and we're going to choose 25 of them. So there's a couple of different ways that we could write our answer here. We could leave it in scientific notation as my calculator's done. This e negative 4 means it's times 10 to the negative 4th power. That'd be one way to write it. Or we could just write it as 0.0089. It's the same thing, just not as in scientific notation. Or if you want to do it as a percent, we could say 0.089%. So any one of those 3 answers would be correct. So one more example together. It says to win a particular lottery game, it is necessary to match the numbers on 5 balls that are randomly picked from 50 balls numbered from 1 to 50. And the number on a special black ball that is picked from 9 other balls numbered from 1 to 9. What is the probability that a single lottery ticket will match the 5 balls and the special black ball? Well, for this one, we know that there's only going to be 1 correct answer. So 1 would go in our numerator. Now, technically, the reason why we have 1 is we have a situation we're trying to pick out of those 5 balls. We're going to choose all 5 of them correctly. And out of that last 1 ball, we're going to choose that 1 ball correctly, which 5 choose 5 and 1 choose 1 would just be 1. But it's much easier just to think of this using common sense and think that, well, it's a lottery, so there's only going to be 1 correct answer. We want to figure out how many total different combinations there's going to be. Well, for that, it's going to be the fact that we have 50 of the balls that are numbered from 1 to 50, and we're going to be choosing 5 of them, times the fact that we have 9 other balls, and we're going to be choosing 1 of those. So to figure out what our fraction is going to be, we're going to take 50 choose 5 and 9 choose 1 on our calculator. Whoops. So again, I always start with NCR first. So it'll be 50 choose 5 times, again, NCR. This time it's going to be in parentheses 9 choose 1. We do that, we get 19,068,840. So we have a 1 in 19 million chance of winning this particular lottery, approximately. And that would be your answer. So that's it. So hopefully now you understand how to use combinations and how to use your calculators to figure that out, and also how to do it by hand. But good luck now as you work on your assignment.